Modern software requirements are rarely linear. They involve a series of dependencies that must be evaluated and acted upon in a specific order. To solve them, you need a system capable of breaking down a high-level objective and executing each component in the correct sequence. A standard large language model is limited by its training data. It has a massive vocabulary and excellent reasoning skills, but it is isolated, unable to fetch real-time data, update a database, or execute code on its own. An AI agent combines the LLM's reasoning engine with functional external tools. The central brain reaches out to a calculator, weather API, or SQL server. LangGraph orchestrates a cyclical loop where the agent observes its output, running processes until the task is complete. Mastering this architecture lets you build systems that adapt their execution path based on the data they encounter, moving beyond the constraints of rigid, pre-written scripts. We start the build by setting up a Node.js workspace. You initialize your project and install the core LangChain and LangGraph packages, along with Zod for data validation. We give the agent its capabilities by defining tools. In LangChain, a tool is a standard JavaScript function mapped to a specific objective. You write a function for addition, another for multiplication, and a mock API call to fetch local weather data. We define a Zod schema requiring specific parameters, like A and B as numbers, so the function executes reliably. If a tool returns a raw integer, memory parsing fails. You must convert the output into a string before passing it back. By strictly controlling the inputs and standardizing the string outputs, you provide the reasoning engine with reliable methods to manipulate data without crashing the execution flow. With the tools built, we initialize the large language model. We securely load the OpenAI API key from the environment variables and connect to the core model. Then we execute the tool binding process. This attaches our JavaScript functions to the model's operational memory, ensuring it knows which external capabilities are available for use. Logic is designed using a state graph. We define a first node where the agent formulates its plan and a second node for execution. A conditional edge connects them. It loops execution to our functions if a tool is requested, or exits if finished. This looping structure allows the agent to handle tasks that require multiple sequential actions, running as many cycles as necessary until the goal is achieved. We test the compiled framework by passing a multi-step user prompt into the system. We ask the agent to add 3 and 4, multiply the result by 10, divide that by 2, and retrieve local weather data. In the first cycle, the language model reads the prompt and recognizes it needs to use the addition tool, passing the numbers 3 and 4 to our function. The function returns 7. Because LangGraph uses stateful memory, this result is saved in the message history. The agent reads this history, recognizes it must now multiply, and passes 7 and 10 to the next tool. After handling the division, the agent enters its final execution loop. It identifies the weather request, pings our mock API, and gathers the forecast. Because the agent maintains state and routes its tools, it navigates multi-step instructions and resolves dependencies without a developer scripting every transition. Checking the terminal output, the agent calculated the layered math correctly and integrated the local weather report into its final response. The language model mapped out the dependencies and executed the functions in the proper sequence, entirely on its own. This same logic allows the agent to move between diverse data sources as easily as it moves between math functions. A simple addition tool replaced with a live database query or a web scraper. Once the tools are defined and the graph is mapped, the agent treats external data sources as modular extensions of its own reasoning, moving between them as needed to complete the task. Mastering LangChain and LangGraph gives you the framework to build software that does more than process data. It reasons through it to find its own path to the solution.